Welcome back to Mathematical Inductions Part 4. So in this one, we're going to answer another example. Yeah, we'll see if we can do 2. Yeah, and then from here now, we're going to the last part, which is the divisibility. Yeah, so we're going to deal with so I've been doing the summation. So yeah, we're looking at the summation, whereby we're given something like 1 plus 2 plus blah blah blah. We have a formula is equal to that. So this is the summation. So now after this, so this is the last video on summation. And now we'll go to the last part, which is about dividing. So how is this word pronounced? Divisibility. I'm very bad at English. I only know how to punch these numbers. Okay, so we can get started. So we're going to we're starting with an example. So make sure you always have those steps with you. Yeah, so step 1, we can even have a recap. Step 1, you prove when n is equal to 1, is the left hand side equal to the right hand side? You ask yourself if n is equal to 1. If it's true, then step 2, you can let n is equal to k. Okay, you let n is equal to k. Where there's n, you put k. You already assume that since n is equal to 1 was true, then even for k it is true. And then we're now going to prove that okay, after k, what value comes next? It is k plus 1. So on the left hand side, you put your k, and then the other value be followed by k plus 1. And then on the right, you are going to, wherever there is k, you'll be putting k plus 1, just like that. And then again, you check. We always do the left hand side. Usually you can start with either. So the left hand side, you manipulate it, and then you check if it's going to give you the same thing that is on the right. Yeah, so this is the basic principle under the summation rule. Having said that, we can go straight to an example. So here's our example. Proved by mathematical induction that blah blah blah. So we're going to test. We'll say for n is equal to 1. What are we getting? So like on the left hand side, when n is equal to 1, we're going to have 1 over 1 plus 1 plus 1. So on the left hand side, we're getting 1 over 2. So this is 1 plus 1 is 2. 2 times 1, 2. So on the left hand side, we'll get 1 over 2. What about on the right? So on the right hand side, we test as well. On top we have a 1, and then we say over n. Here we have 1 plus 1. So obviously you can see this is also 1 over 2. So for n is equal to 1, the statement holds, it's true. So since it's true for n is equal to 1, then we can say it is also true for n is equal to k. So in that original expression, wherever there was n, we're going to put 1. Okay. So we'll say, what did we have? We had 1 over, so we had 1 over 1 times 2 plus 1 over 2 times 3 plus and then 1, we have 1 over this is 2 times 3. So having so the function we have is 1 over 1 times 2. We have 1 over 1 times 2, 1 over 2 times 3, and then 1 over 3 times 4, and then plus going all the way. Obviously you can even tell that maybe the next one will be 1 over 4 times 5 plus now the formula 1 over n 1 over n plus 1. So this is equal to n over n plus 1. Okay, so that is the what we have. I was just writing down this 1 over 1, 2, 2, 3, 3, 4. Yeah, that's what I was writing, and that's what we have here. So we're now letting n is equal to k. So we'll write all of these 1 over 1, 2 plus 1 over 2, 3 plus 1 over 3, 4. And then we have 1 over, what is n? We're putting k. 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 Easy stuff, not so. Okay, so this is Eka plus. So I've let n is equal to k, and then now after n is equal to k, we now say k is equal to k plus 1. Okay, so this is the part where your attention is needed a lot. So now we're going to let we're going to let k is equal to k plus 1. So from the original expression which we had, We have 1 times 2, we have 2 times 3, we have 3 times 4 plus going all the way. So okay, yeah, always remember this part which is having to my plus plus to my dots, we'll substitute it later on. Okay, so plus 1 over k. Oh, I think, yeah, this is the part. So like you should take note of this. So like the whole lot of this later on, while there will be all this, we're just going to put uh, k over k plus 1. Yeah, that's what we'll do. So here we're just, so now we've reached the point where we now want to let things equal to k plus 1. So firstly, you write the whole lot of this the way it is up to this point before the equal sign. Yeah, so that's the part I've reached, k plus 1. Okay, so this, it is this one which I've written here. Okay, so which is pretty much the same as, we're going to substitute with that. So after writing this term here, you have to know what follows. What follows is, where there's k, we put a plus 1. That's the next term. This is the part where I've been saying here, we're just having a lot of things. So if like the whole lot of this was 8, we could have put 8 plus 1. That's the next term. So, but since we have letters, it means while there's k, we put k plus 1. Even here, we put k plus 1. Okay, so we'll say 1, we're going to have 1 over this is k plus 1. This is just for this one which is outside. And then we come to the other one, which will be k plus 1. This one, it is the one here, k plus 1, but it also has like another plus 1. It has this other plus 1. So this is the left hand side, it is equal to, so this, wherever there is k, we put k plus 1. So meaning on top, we're going to have k plus 1 over, down here it's going to be k plus 1. But since we also have another one, we write it like that. So from here now, we're going to say, we can simplify where possible. Yeah, so mainly these which are having plus 1 plus 1, we're going to have 1 over 1 times 2 plus 1 over 2 times 3, 3 times 4. Plus 1 over, so this will be 1 over k plus 1. We have reached this point, and then plus, here we have 1 over, this will be k plus 1, which is for that one, And then here, this is the part where we just want to simplify. So this is 1 plus 1, it's 2. So these are equal to k plus these are equal to k plus 1, which is there, over k plus 2, because 1 plus 1 is 2. Okay, so here, whenever you just notice that you have substituted k plus 1 and you have simplified on the right hand side, you just have to now start working. This thing on the left, it should match what's on the right. So we do with the left, hand side. So under the left hand side, this part which is having two dots, you can just get this as a negative. This part which is having a dot, we usually replace it. It will be substituted. So this part which is having dots, it is that one which I highlighted. So the whole lot of this here, it is just the same as this one up to this point. So the whole lot of this is actually, you just put k over k plus 1. Okay. So everything up to here, it is k over k plus 1. Plus, so we have this term before the equal sign, 1 over k plus 1 and k plus 2. So it is this left hand side, want to see if it can look the same as the right hand side. Okay, so now moving forward, we can express as a single fraction. Yeah, so we express as a single fraction. So how will this look? So we have to look for a common denominator. So for this, we can just multiply, but here what we have, it is just like if we have 1 over 2 plus 1 over 2 times 5. So 1 over 2 times 5, it simply means 1 over 10. So like, what is the common denominator between 2 and 10? So the common denominator is 10. And then you say 2 into 10, and then you multiply by the numerator. 10 into 10, you multiply by the numerator. So this is exactly what we have. The common denominator is this, because k plus 1 can go into that. It simply means it will cancel. We remain with k plus 2. Okay, so meaning our common denominator, let's put it, we have k, we have k plus 1 and k plus 2. So k plus 1 into this expression, it simply means k plus 1 will cancel k plus 1. So meaning we remain with k plus 2. And then according to the rules, this k plus 2, we multiply it on top there. So k plus 2 times k we get, we're going to get k squared, we'll get k squared plus 2k, 2 times k. Okay, and then now we divide this into that, so they're just the same things. It's like both of them they cancel, so it's just 1. So this into that is 1, so 1 times the 1 on top we just have a 1. Okay, that's what we have, just a 1. And then this is the part where we try to simplify further, so we can factorize this. So in the previous video, part 3, we had a polynomial, we had to reduce it using synthetic division. So, but this one is a quadratic. We can find the product, sum, and factors. So the product, 1 times 1, it's 1. Our factors, the sum, it's 2. And then factors, so what numbers can we add together to get 2? I think it's 1. 1 plus 1 is 2. And again, 1 times 1, it's just 1. So meaning our factors are 1 and 1. So k squared plus 1k plus 1k, again plus 1k. These are our factors because 1k plus 1k is 2k plus 1, everything over k plus 1 k plus 2. Okay, so from here we can factorize. We can factor here. We factor out a k, we remain with here we remain with k into k, we remain with 1 plus here there's no common factor, so we factor out a 1. That's the common thing which can go into both. 1 into k, it's k. 1 into 1, it's 1. So everything is over k plus 1, k plus 2. So at this point now we can get the like terms, or we can get our factors. So our factors are k plus 1, like this. Wait, so we're just having k plus 1. Okay. And k plus 1 over we say over k plus 1, our fraction, and k plus 2. So at this point we can cancel one of the k plus 1s, so this cancels with that, meaning we remain with k plus 1 over k plus 2. So we're going to remain with k plus 1 over k plus 2. So this leads, it has taken us back to what we wanted to achieve. So here on the left hand side, we were just busy working with this. So we are working with the left hand side. to try and see if we're going to end up with the right hand side, k plus 1 over k plus 2, and we have achieved that. So I've proven by mathematical induction that the statement is true. Yeah, so I think we have a fair share of the summation. Alright, so you can try out many more examples on this. Yeah, try solving a number of questions. Practice makes perfect. Yeah, so make sure you practice. Yeah, practice. I want to show you the tutorial sheet you can work on. Okay, so this is the tutorial sheet for mathematical induction. So you should be able to work out questions like this one, or from doing this one, question B here, it is the one we're just from answering. So you can even do this one, and then you can try the other ones as well. Yeah, so for the rest of these, they'll be made in form of a document, and then the solutions will be sent. Yeah, so under mathematical induction, we're now remaining with what we do with division. Yeah, so we're now going to learn on how to answer under divisions here. You should be able to answer these. Yeah, we're going to answer such questions. So that would be mathematical induction part 5. Yeah, we'll answer these, and then the last part, we're going to have part 6, where we get to deal with inequalities. They are very much similar to the summation one. Yeah, so I hope this is where we'll end. And then from mathematical induction, we have to do some binomials. Okay. So this is where we end with this lesson. Make sure you go through what we solved and just take note of the steps and what is involved, and you should be good.